Hi, everybody. I'm Arthur, and yeah, welcome to the third part of the deep dives around the benchmarking framework. And today, Alexander, myself, and Tarek, we're going to demo a more practical use case around the benchmarking and how to benchmarking a palette. So here is the agenda. First, we will just do a quick recap about the first and the second deep dives. And yeah, then we'll cover a bit of the benchmark palette, the weights template, and Tarek will do a walkthrough from beginning to end of the workflow and how to benchmark things. And last but not least, Alexander will cover the new benchmarking version 2. So let's do it. Yeah, a quick recap in order to get the substrate subcommon benchmark, we need to build it, the substrate node with the profile production and activating the feature runtime benchmarks. And once we run it, we will have all these commands that in the second session, the previous one, uh, we already covered it very well, so you can just stop here and go there to take a deep look into each one of these uh, inner commands from this benchmark subcommand. And yeah, so let's dive into the palette one. So yeah, we selected the create extrinsic of the assets palette in order to analyze it. So yeah, we have this weight info create here, and it's pointing to this piece of code, and we can see 28 million here, something. And also the second number, it's more about proof. It's called proof size. It's more about the collators and the proof of validity that they sent to the relay chain. So we are not covering this now because we are running a solo chain, substrate solo chain. So let's stick with this 28 million. And we also see that there are two reads and two writes operation here. So yeah, and so so we have this. So how can we compute this weight unit, the really the final result? So we have this reference here, and yeah. So as you can see, the dB weight is like we have different weight units for the read operation and a write operation. So I put everything here. So at the end, this create extrinsic should has a 278 million weight units. And once we send the extrinsic to the solo chain, we can use Polkadot.js to inspect the final weight. And we see that there is something wrong here because we were expecting 278, but we got 378. And why is that? So in order to debug it and inspect it, we decided to put a zero and on the weight of the create extrinsic and recompile the runtime and also again send the same extrinsic. And we see that by zeroing, we still get this delta. It's the almost 100 million that we were looking for. And that is exactly what it's the weight, the base weight unit that we have for every extrinsic on the standard node of substrate. And yeah, so in order to, we also decided to zeroing the frame system remark, and we just send it, and using Polkadot.js, we get exactly the same weight unit here. As you can see, it's now the system remark with different events, so different logic, different database state access, and yeah, but the value is the same. So it's the like a base fee of every and each extrinsic there. Okay, so next thing is that we want to cover here is the template. So in order to really get the value, we generated using the benchmarking framework. So we have this template for, and this is the again the palette assets command that was ran in order to get that 28 million weight units. And as we can see here, this is a snippet from the benchmark CLI README file, and the template use handlebars. Handlebars is a templating language, and at the end of the day, we use it just to inject text inside this template. I will show you a bit in a bit. And yeah, important things here is the steps and repeat. I mean, we already covered it, but cool thing is that we do insert a header to every in each template weights file. So we have a header option here and the template here. So let's see how this template looks. Okay, so here it is. I think the size is cool. And yeah, like I said, we have the header here, and yeah, the handlebars language will inject things here, and we are saying it to inject this header of Apache 2 license, and the file is, I think I already have it here. Yeah, so this is the file that is being injected here, and all these things. So the final result of should be running, and here it is. Yeah, so we have the header and then a bunch of info. And yeah, so just a heads up here, keep in mind that this must be a Rust code, a valid Rust code. So we are really using this output of the template during the compilation of our palette. So we can just change things here and not be sure that it's a valid Rust code. And yeah, so in order to tweak it a bit, I created this new template file. So my aim here is just to like make it two tabs here, like this. And yeah, so we can also maybe, oh, okay, so I don't want to insert any header. Instead of, I want to, hello, deep dives, folks. And yeah, I mean, we can change, but again, this is a comment, so it's still a Rust, a valid Rust file, and let's run it. So we have the new, using the template new here, outputting this new. It's very quick because I'm using the, I'm just benchmarking the create extrinsic here, not every extrinsic from the assets palette. And the output now is this new one. So yeah, as you can see, we are not getting any header. Instead of it, we are just putting this, and we got this tab. And I can show you just the difference around this was an if and else case, just to print it more like a cosmetic thing. And yeah, so another cool heads up that the latest change in this template was pointing this import to the right things as we updated it, the phantom data. So yeah, if you want to change or use your own template, keep in mind to always be very aware of the import section of your crates. And yeah, so it's pretty much it. So getting to, yeah. Oh yeah, another cool thing is that I'm using a M1 CPU, and for some reason the benchmarking framework's not detecting it here, so we can also just hard code it here if you want. So yeah, and that's it. Okay, so yeah, this is the command. Just if you guys want to run it locally, and this is the using the frame weight template, the official one that we have in the substrate repo, and this is using my new template, and I also removed the header section here. So yeah. And now I will leave it to Tarek to cover, to do a walkthrough with you guys. Thank you.
Cool. Hello, everyone. So I'm going to actually do a walkthrough on the necessary steps to get benchmarking working. We covered a lot in the last learning session about some of the code and the steps to write the macros given a certain palet's extrinsics. And today I'm kind of going to cover the actual steps from beginning to end on what's necessary to get these benchmarks working. Cool. So the first step is to take care of the dependencies and features. And within your cargo toml of your root directory for your palette, you're going to have to add frame benchmarking to the dependencies. And inside of your features, you're going to have to add inside of your standard feature, this frame benchmarking standard, and to add a runtime benchmarks feature. Now, a really important note is a lot of these features that we use are additional from support and system. And that means we'll actually have to import this ensure macro and ensure origin and get trait as well as system trait. Cool. And from system, this raw origin. Awesome. So let's just go over what this would look like on a very standard level. So you're going to import your palette. We'll import frame benchmarking. And in this case, we're going to just demonstrate V1 as Alexander is going to demonstrate what V2 would look like. And then, as you can see, we have this use framework, use frame support, which is importing this ensure macro and these traits, and then this use frame system. Now, this is an example of the identity palette. And we'll have a helper function called add sub accounts, which is just adding these sub identity accounts. And then inside we have this benchmarks macro that will test or benchmark the remove sub extrinsic and verify it. Cool. So now we have to test this benchmark. And there's a super useful macro called implement benchmark test suite. And this is just a way to actually run the tests that benchmark macro generates. And the benchmark macro generates a sample function like below where it says function bench remove sub. And every time you add any benchmark within this benchmark macro, it's going to basically generate this code for every single one. And then implement benchmark test suite will actually run it. And a good example on how to run this below is this cargo test package palette and then features flags. And yeah, you could just run this to see what that will look like. So let's do a little deeper dive into this implement benchmark test suite. This implement benchmark test suite takes in about 6 parameters. Usually you'll only actually use 3 as 3 is only necessary and the second 3 are optional, but let's look into what they are. The first one is just going to be the module, so like the path to the crates module. And that's super simple in this case, it's just going to be identity. And then the second argument is going to be this new test extrinsic. It's a function call which returns either SPIO test externalities or some other type of similar interface. And our third argument, test, must be the path to the runtime. The item to which this will refer will generally be in the form of this frame support construct runtime macro. Now, our fourth argument is optional, and It's just the benchmark path. And what this means is, let's say you invocate this implement benchmark test in a different module than the benchmarks. This is really important because then you can just point to the path and where you invocate it. And this fifth argument, which is also optional, is just an extra Boolean. And by default, this generates a test suite which iterates over all benchmarks, includes those with mark extra notation, annotation. But if you have any attribute that has that extra attribute, setting it equal to false will exclude those. And then the sixth argument, which is also optional, is just exec name or custom execute name. And by default, this uses execute with for this param. There's a bunch of special cases to this, and it's not very used often, but it's basically for setting a custom name to your execution. And when you run this command here, this is what this sample output looks like. And as you can see, the benchmarks are really just generated tests. So you're going to see a very similar output to any tests you would actually run. Cool. So after all that, we actually have to add our benchmarks to the runtime. So let's say you build your palette in Substrate and you want to import it into Polkadot. So we're going to have to do something similar that we did with the actual palette itself, where now let's add the palette to the dependencies. And let's also add that runtime benchmarks to the features in runtime benchmarks, and let's also add the palette to the standard features. And this would all be in the cargo toml in the root of your runtime. Cool. Now, this is a little off of the actual benchmarks, but just to do a brief overview, you're going to have to add your palette config to the runtime, as well as the palette to the construct runtime macro. And this is just necessary to get your palette working within the actual runtime that you're adding it to, and is just a necessary step to get to the benchmarks working. Cool. So within this runtime too, now we want to add our palette identity or whichever palette you're importing to define benchmarks. And basically what define benchmarks does is it uses two macros that the benchmarks library gives to us, which is add benchmarks and list benchmarks. And this would be the most necessary step to add that benchmark to your runtime. Cool. And just as the last overview, you guys have seen this a bunch, but this is just the command that we would do in order to run these. So we would build our repository with the features flag for runtime benchmarks. And then, as you've seen many times, we would just run this using the benchmark palette command. And that's it. And we'll pass it off to Alexander. Thank you.
Okay. My name is Alexander, and today I will show you benchmarks version 2, which is the new and better syntax for writing benchmarks. And let's start with a quick revision of what we already know about the benchmarks anatomy for version 1. So here on the slide, you can see a benchmark, which consists of the following components like name, arrange section, that is basically some code that sets things up to run a benchmark. The act part, that actually is the most critical one. This is exactly the code that is being benchmarked. And some verification step that is optional, but it's better if you have it, because in this case, your benchmark can act like a test. And now switching to the same thing, but for version 2. So a benchmark in version 2 basically consists of the same things. It has a name, but now name of a benchmark becomes the name of a function. A range and assert part now becomes a perfectly valid Rust code. And the extrinsic call is now marked with extrinsic call attribute. And we like this syntax more because this is a normal Rust function. and it looks very much similar to an ordinary Rust test. So looks much better. And saying that, let's do some live coding and actually try to rewrite some old style V1 benchmark to a new version. And for this, I opened a Substrate project, and here I'm opening up a random palette, which is ranked collective palette, open up benchmarks for it. And as you can see, it currently uses old style benchmarks. So here is a function like macro that is responsible for generating the benchmarks. Here you see the name, the setup, the call, and all that kind of stuff that we already get used to. So let's start rewriting it into version 2. And the first thing that we want to start with is we are commenting out the imports for version 1 because these guys, they cannot coexist because they have macros called the same way. So we are importing version 2 now and commenting out the whole benchmarks. And we'll be rewriting this guy. Because first we need a container. So let's start defining a container. Container for V2 benchmark is a modal. So let's go with the modal, call it benchmarks. This guy needs to be annotated with an attribute. See, it's called instance benchmarks. We use this one because our palette, collective guy, is actually an instantiatable palette. You can see here, it has the second argument in its type constructor. If it were like more traditional, more common singleton palette, then we would go like this without the instance part. Okay, then let's import everything from the other scope and define a benchmark, which is just an ordinary Rust function. Put in here. And here we need to annotate this guy with another attribute. Okay, and let's just start copy pasting. And the first thing that we see here is that this generation of an end parameter, as so multiple guys already said that our benchmarks are so they can have parameters are parameterized, and we have this thing to generate values for these parameters. And in use syntax, this becomes a function argument of a type linear, which is actually good to have because like several people before me already told, our benchmark engine internally relies on a linear regression. So we assume that the complexity of your function that you are benchmarking is like linear bounded, which is absolutely not obvious from this syntax. But so it's good that here we explicitly say this guy is linear. So semantically, this syntax looks much better. Then we just copy paste all the rest. And the call part. And remember, we have to annotate it with extreme attribute. And then the verification part. Let's check if everything works. And it doesn't because in our, as you can see, we have type linear in our palette. So there's a conflict which we need to solve. Yes. I assume that this guy will work now. Okay, cool. No errors. I will cancel the but if there were errors, you will already see that. The next thing that I would like to show is that if we look at the first benchmark in this file, you can see that it doesn't have a call to an extrinsic, but instead it has a code block. And this is also possible to do with a new syntax. So instead of an extrinsic call, we'll have to specify block attribute and write a normal Rust block. Okay, but as you can see, Rust says that underscore is not allowed here. This is because block has to be like a perfectly valid Rust code. So let's fix it, calling the function explicitly. Do it like this. Okay. Oh. Okay, no errors. And the next thing that you might have noticed is that, for example, the old syntax allowed you to use a question mark operator, like as you can see here. But the problem with this is that it only can be used inside a function that returns a result. So if we try to use it here, we'll have an error. So you can't use a question mark operator in a function. So this issue is also addressable. We can update the function signature the following way. And in this case, we'll need to return a proper result of the function. And as you can see, it all works now. And I think that is basically what I wanted to show.
Thank you all for joining us on this. This was amazing, and really appreciate it. Thank you all.
Thank you, guys. See you.
Thank you for your attention.